Okay, so exception is the one of the good preventive programming skill for software design and development. And recall last time when we asked a survey question, how do we prevent the bug from a software from happening in the first place? Exception and assertion is one of the tools many program languages will offer. Java also offer exception and assertion, and Python also have the exception and assertion. I don't remember whether C have it, but I definitely know C++, C# will have it. So this concept is not really new, but Python has its own implementation of this. If you Google Python exception 3, so let's see, you will see a lot of document on Python exception. In fact, exception is a Python class. So it's and you can actually write a subclass inherited from this base class to modify, to customize the exception. There are actually many exceptions. I don't remember, certainly there are so many of them, I don't remember many of them. And also, remember exception is the language-specific implementation. Apparently from Python 2 to Python 3, there are also changes, and some of the previous exception will be reorganized or put in a different subclass. And so that means previous code may or may not run, depending on whether the Python, how Python implemented. And what makes things more a bit frustrating sometimes is Python 3 decided not to be backward compatible with Python 2. It's probably a good idea because Python 2, I guess they have some design problem. They want to just get rid of it. Don't even have the backward compatibility. So they want to redesign Python 3. But that also means old code cannot be run. Actually, it's like the old Windows XP. It's not even support anymore. So in a way, you can, if you think about software design, Python 2.x is not well thought out. That said, I think Python 3, in maybe another 5 years, will probably be replaced by another version of Python. It's already 3.9. So 4. Is not that way out in the future. So, okay. So, but right now we are dealing with Python 3. But you can see some of the lecture materials still has some Python 2 something content there. It's really hard to change everything, especially for slides. Okay. So, but from the practical perspective, when we write Python, use exception to handle errors, very often you can actually intentionally to make an error to see what kind of error it is, right? So in this case, this is an index error. So that's the list. If I index 3, it's going to tell me 3 is like 0, 1, 2, 3. 3 is not even there. So this will give you an out-of-range index error. So this exception will be something called index error. And if you want to handle it, that's the name of the exception, index error. And then there are also this kind of error. if I want to put, remember the first X is a list, right? So if I want to convert that list into an integer, it's going to tell me, no, that's the wrong argument. In fact, it expects the argument to be a string, not a list of numbers. So that will be an input type error for the parameter. And then there are other things. If I put a hello there, it's going to tell me it cannot convert hello into an integer, and that will be something called the value error, because hello doesn't correspond to a floating point or actually integer here. So, and then there are also another type of a variable has never been defined before. So here I have not defined this as a variable. So if I try to call this, it's going to tell me it cannot even find this variable. It's just a name error. This is actually very common when you have a typo, right? If you have a name function, you type it with a typo, then the Python interpreter will complain, say it cannot find it. But if that say it cannot find it, it's going to say that a name is not defined, it's a name error. So, and sometimes when we input a file name, the Python cannot find it. And in Python 3, it's something called file not found error. In Python 2 point, something is actually called RO error, input output error. But in Python 3, all the RO error or exception are now become part of the OS error. I actually do not read the discussion why they want to make this change, but apparently the Python 2.x, the input output exception error now all belong to the the OS error now. So if I say just want to open a file, it's going to say file not found error now. I think I'm running Python 3 something. It's probably, I'm not sure what the Colab current version is. And this used to be in Python 2, this used to be something called RO exception, RO error. So, in a way, I mean, Python is a language, it's also changing. So that's, you have to follow the new language syntax and the definition. Yeah, so actually give a link there, so you can actually read it. There's some discussion why I guess there are some good reason why they want to do this, but it's that what it means is make running the legacy code a bit a headache, right? So if you try to run a code from before 3.3, and then you will have an error because or something doesn't run very smoothly. So, okay, that's basically what Python is. I'm sure in other language you have similar issues. The Python exception usage basically is you have to try something and then you use the keyword try and accept. So that's the syntax, I guess. And this is the actual example. We are trying to show how to handle the input error. So I have a while loop. Basically, we are going to try input a number A and B here. So input an integer, and then I convert that into integer. And then we just do some simple arithmetic, print out the A divided by B, and then A plus B. And then we try to handle some exceptions. So this is a try block. And then followed by, notice there are 3 exception blocks, and they are handled sequentially. So if there's a value error, and that means we cannot convert something, either A or B, into a number. And if there's a zero division, because there's a division here, if B is 0, then there will be a 0 division error. And except there are some other error exceptions, there will be other things. So, and then we just prompt the user whether we continue or not. So, and the way I handle this while loop, basically have a traffic light. It's a green light, we keep doing it. If it's a red light, we stop it. So, okay, so let's try this. Well, let's just do it correctly. I'm going to put 1. The next number is 2. Okay, everything is good. 2.5, 3. Continue, yes. Okay, now let's try to make some mistake. So I'm going to put 1. I'm going to put 1. Right. 2. I'm going to let's make a 1 error at a time. Okay, 2. I'm going to put 2 there. So what? Oh, sorry. Tell me one number. Oh, it actually immediately gave me an exception here. Cannot convert to a number. So before I even input a 2, sorry. Let me try this again. If I put a 1, yeah, it already says cannot put into a number. That's because I do the integer conversion right here, right? So before I even had the chance to input a second number, it's already through an exception there. So, okay, let's try again. This time I'm going to put the first number correct. Continue. Yeah. This time I'm going to put the first number correct. Second number is wrong. I'm going to put a second number as 2, which is a word. Right. So what's the error here? So cannot convert to a number. So now, what this means is, now tell me a number, I put 1, that means this line wrong. But the second line, B, is integer with the input, tell me another number, not throw exception error, which is cannot convert the number 2 into integer. So, okay, so what else should we do? Notice what I'm doing here is also something called a glass box testing, because I'm reading the code, trying to go over every branches, every step. So what I'm trying to do is so-called a path complete testing. So, okay, so let's try. So we have tested the value error. We are going to testing the 0 division error. The 0 division will cause if I input a B as a 0. So I'm going to put 1 is 1. And the second number, I'm going to put a 0. Very good. It says cannot divide by 0. So that this works. It actually catches a 0 division exception. So now this actually, I couldn't figure out some other kind of error. So actually, I still, anyone can think of some kind of error. We can go to the last except. That is there just as the safety net, I guess, because there could be, the user could input something we haven't anticipated yet, but I actually still haven't thought of what kind of thing the user can still put it in. So let's.
What about a symbol?
Okay, good idea. So put a yes, put a $sign. I think that would be probably just a number cannot convert to a number. Yeah, it just cannot convert to a number. In theory, you put a very large number, it can run out of bound. But I tried it. I never be able to reach that number. So if I put I'm sure that's still very small. It's not big enough. Yeah, it's still not big enough. So yeah.
Can you do that to like the power of 10 or something?
Say it again.
Or actually, never mind. I guess you can. I was gonna say, can you just do that to like the power of 10 or something to make it even bigger? But
now remember, this is the input. It doesn't execute that power on your input line. If it's a variable, I mean, it's hard to, I can put a power. But remember, this is a string as an input. So if you put power, it's going to just interpret it as a number. In fact, it cannot convert a number. Yeah. So it's in a way, yeah. So that principally it is a good way, but it doesn't work here because everything you put as a power will be interpreted as a string. So yeah. Anyhow, something for you to think about how to go to the last exception. So in a way, what I'm showing you here, even though this is glass box testing, I still haven't figured out a way to trigger the last branch. So even though I'm trying to do a pass complete, but haven't figured out the condition to reach that pass complete testing cases. Yeah. So in theory, glass box testing should be, but in practice, sometimes we just don't have the time or the energy to testing every branch. Yeah. So okay. So I need to now stop this and continue or not? No. Okay. So now I stop this. So this is a very simple, kind of simple. I mean, syntactically. Yeah. So try except as the example of use exception in Python. This is, I mean, not very complicated, but we can actually do many more. With the exception, you can do some fairly complicated things. Those are just some example again. So in this case, we are actually trying to make sure the user input the number we really want. So basically force the using exception to force the user to put incorrect input. It can be annoying actually, but this is just a exercise to show how this is done. So while true, remember that's an infinite loop. It will only break when the user input the correct one. So this is the quite a strict implementation. Use exception to force the user input put what the input the software engineer wants. So okay, so we have this infinite loop. Force the user to input integer. If it's not, you just go back to the loop again. So let's try this. If I say 0.05, very good. It's not an integer. Try again. 10.0, it's not integer again. So 1, it's not integer. What other thing we can try? Hello. 1 to the 10th power. That's actually considered the word, I believe. Okay, let's try again. 99,000,001. That is the integer. Finally. So this is just I actually if I'm a customer, I'm probably annoyed. But this is just example. You can force the customer to input the correct one. So okay. So this is use the exception to make sure the user can follow the instruction here. So there are also other a bit instead of the very simple try and accept, there are 2 more keywords you can use. Is something called else and finally. So this actually can break the sequential run. Now, else is actually a logical branch, right? So the finally is providing almost like a base situation to make sure that section is always run. So okay, so in this case, I'm going to need an input file called data.csv. But that data.csv should be part of your downloaded zip file on the Canvas site. So if you let me also make sure that is the case. So download. Okay, yeah. It actually has two data files, data.csv, grid.csv. So, but since I'm working on Google Colab, I need to upload those files into the Colab. So the way you can do that, on the left-hand side, you see this folder icon. So it's actually called files. I click on that, and then there's the upload arrow. So I click that, and then I'm going to upload that two files, grid and the data.csv. Very good. So, yeah, it's there now. So grades.csv and data.csv. We just to make sure it is there, so I'm going to also check my current Colab working directory. So I'm in content, and then listing the file. Okay, I can see it now. See grades.csv and data.csv. That's the, by default, that's the file directory Google Colab offers. So on the Google Colab, remember there are magic commands, and so I can run some shell command just to see what's there. So the data.csv file basically contains a pair of the key and the value. So this is basically a dictionary in a CSV file. There's 1 to 1, 2 to 2, 3 to 3, 4 to 4. And what I'm trying to do is read this data and put that into not a dictionary, actually a list of lists in this case. So okay, so the code is I have I'm going to first create an empty list data, and then I'm trying to read that file. Actually, this one code, that's just file name. Notice I'm trying first read that file and then accept. That's still called RO error. I haven't changed it. And that should be OS error. Or file not found error. RO error, in this case, RO error probably still runs, if I recall. Let's still use the RO error. I remember this particular error is still backward compatible. Let's try this. If not, I'm going to change that to OS error. It doesn't look like it worked because my point my mouse there, it still shows the definition of RO error. So it looks like at least Colab have that implemented. So let me just leave it there because it's actually show up. So that's a correct keyword here. So, and then now I see else. So if there's an exception, I'm going to catch it. If it's no exception, we are going to execute. And then finally, we close the file. It's always a good idea to close the file. So this is also something called a secure programming practice. Right? So if you don't close the file, and then someone else may have a chance to inadvertently modify it or intentionally modify it. So in the worst case scenario, someone can add a virus or a worm at the end of your file. So, okay, so now we have that open. So we just, for every new line in that file, if it's not empty, that's just a regular expression to show end of a line. If there is a one line, all it has is just an end of a line sign, that's an empty line. So we skip that. Otherwise, we remove that end of a line and split by comma. What this means, now I have two elements, right? So we have one, a letter one, and a number one. So, and then we just append it into the data. And so let's see. Okay, the file name. So I'm going to, the actual file name is what? Data.csv, it is this. So let's just run with the correct file name. So, oh, actually look like I didn't copy paste correctly. Data.csv, so. Okay, the print line is at the bottom. So the data looks like this. So if we look at it, a letter one, that's the key value is one, and except currently it's actually list of list. So letter two to two. This is correct, right? So now let's intentionally put an error there. So I'm going to just. Well, remember, the first time I missed the one letter. Let's just try that. ATA.cs. Well, it actually says cannot open data.csv. So this is basically the RO error still work. If I change that to OS error, that should also work. That's so if I change that to hello.csv. Yeah, it also works. So, but I guess for the peace of mind, change that to OS error because at least 3.9 support hopefully will be still be incorporated in the subsequent Python version. Right. So, okay, but for now it looks like RO error is still recognized. Because this is interesting because now I trigger the error, so the data is not updated. So data now is empty. Yes. Yeah. So. Okay. So the next example will show us how to handle more a bit more complicated than the first. The first one. Notice this file is highly unusual for a real data set. If you look at any real data set, very often they have some abnormality. The next example is trying to handle irregular entries in a data set, in an input file in this case. And this one, we are going to use a file called grids.csv. Okay, it's there. Actually, it's also here. So the grids.csv, it has last name, first name, grids, last name, first name, grids. Okay, that's good. Except look at the last row. Last name. I'm actually not sure what. I think that's the first. That's actually not the middle name. That's the German way of something like song of something meaning. If you watch Star Wars, that's. I'm not sure what's the proper term for that. But anyhow, this person has a three-letter name. Baron von Richthofen or something. Okay, so that's the irregular row there. So. We're still going to put the data as the empty list and file name. Those are the usual exercise. But here actually, in this one I corrected. Instead of RO error, I now call it file not found error. This file not found error is basically a subclass of the OS error. What this implies is the Python exception is a class, is an object-oriented design. So file not found error is the subclass of OS error. The OS error is the subclass of the ultimate exception class. So, okay, so we try open that, and that's actually 2.x. This is after Python 3.3. So, and then else we try to process the file. For every new line, we split that and add it. This will actually won't handle the data properly. So let's just run this probably it's easier. So it's called grades.csv. Okay, so hopefully it has that right again. Yes, yeah. So look at this process. So we read out the data, and then we're going to take the first two as the student name, and the third one a student grade. Someone seems to have the microphone up. And then we are still trying to handle that. Handle an exception for the index. If there is no grade, we put nothing there. But you can see the error is there. So Von Baron, the grade is what? Richardson, and that's incorrect. But this one is actually correct. Bill Gates has no grade. Let's double check. Bill Gates, yes, Bill Gates has no grade. I guess Bill Gates dropped out of school. Sorry, that's a joke. But you can also, there's an error here. Deadpool is just one name, and it doesn't have a. So let's see what's up. Yeah. Oh well, Deadpool is actually. No, that's wrong. Deadpool put it as a grade as a name. So that's also an error. So there are three errors. So, what any other error? It seems yeah, that's the three errors. The reason is because what? This line is because not all students have two names. Sorry, not all students have two-word names. Right? So some students have the one-word name. This is one-word name. This is two-word name. And this student is two-word name but no grade. Oh, sorry. Actually, two grader is handled correctly. That's this is this. So the two grader is handled. The non-two-word student, that is not handled correctly. So. So let me, I think I've been talking all the time, so let's make it a bit more interactive. So I'm going to ask you, put some suggestion, how we are going to modify the code to handle the irregular names. So this is just for participation, it's not going to count. So. Okay, the question is, we have this kind of error, right? So there's a three-word name, there's the one-word name, and they are grade and not handled properly. How do we modify the code to process the grade for those irregular names? So that's the question. So. Okay. It looked like after middle term, the participation become lower. There are actually 34, 35 students in this class. But then there are only 20 some students here. So,
What was the question?
oh, question: how do we fix the? Okay, oops, sorry. The question is, how do we handle the grade of these two, Deadpool and Van Boran Richardson? How do we handle these two rows? Okay. Those are probably a famous person, the last one, but I just don't know. Okay, I see. Very good. Someone say use condition. Yeah, we can check that. We can check the condition for the listing. Fixing the choice. Oh, I guess you mean this one. Yes, yes, that's correct. We should try to fix our statement, but you need to explain how we are going to fix. Oh, something in the chat room. Oh, something in the red baron, a famous pilot in World War I. Okay, well, thank you. So, that's interesting. Red baron. Okay. Okay, so create a case if the type of student who is a student. Yes, that will be good. I mean, you check the last one, whether it's the number or not, or a value or not. Use the exceptions. Yes. So fix the, no, that is the symptom, not the cause, right? So printing is just printing the error. So remove those. Okay, no, this is interesting. It's actually going to change the input. Just remove those rows. Well, it certainly will work. It will be a quite ingenious solution to a problem. Okay, basically, if people didn't put the data correctly, we just ignore them. So interesting, though. Interesting solution. It actually will fix the problem. So maybe we could check the type before putting the yes, yeah. So it's an interesting way people come up with how people come up with different way to address the problem. So that's kind of a interesting way to do. It's certainly creative. So okay, let's see. The textbook actually come out with a bit ingenious idea. So let's see. Here's the textbook solution of that problem. Can someone explain? Let me open up. What does the textbook do here to fix that problem? It's not perfect, but it actually worked here. So what do you think is the textbook solution to solve that problem? So to solve this problem, sorry. I mean, obviously you can run the code trying to figure out, but if you can look at the code, explain it, that means you really understand what it's trying to do here. So it's not perfect, but it works here. So I'm going to highlight this. So this is a textbook solution. it's kind of clever too. So
Do you want us to explain it in Socratic?
yes, yeah. Sorry, I guess didn't mention that. Didn't make that. Yes, in Socrates explain this 3-line code how it handled that name irregularity problem. So. Okay, good enough. So it looks it's very good to use assuming there's a problem for the last one. Yes, yeah. It's basically looking for the last one. Yeah. And the rest of it treat as a name. So yeah. Yeah, very good. Yeah, this is actually quite an ingenious idea. So. So let's test this. So, very good. It actually worked. Yeah. So. I guess Bill Gates, that one probably had an implicit white space there. So that's also why the Bill Gates one worked. So yeah, it's quite an ingenious idea. So very simple, but that's it. It's not perfect. I mean, you can imagine there are different ways to break this. So nevertheless, it's a good exercise. Okay, so. Let me quickly go over the rest of it to finish this. So, so Python also offers ways for us to customize the exceptions. So when we raise the exception, we can actually raise the exception with some customized warning messages. So this is an example to put the ratio up to number. If there's a 0 division, we print out the 0 division error, raise the floating point as error. And then if it's the actual value error, we put customize the message called bad input argument, something like that. So, okay, let's just see this. This is correct. And this should give a 0 division error. Very good. Well, instead of print out the wrong thing, it actually put not a number there in the output. So this kind of a so-called silently handled exception. This is probably good for many numerical analysis, like deep learning. If the user misinput something, you don't want the whole project gets hard and fall. Instead of put some so-called imputing number there and still let the entire project run. So this is something called silently handling this behind the scenes. And we could also implicitly say this just, there are some situations we just really halt the entire thing, right? So, and then this will be the next one. So this one actually halt the entire thing. Actually, look at this. It actually says print out the error message. We put it here. So this is the customized warning message. So if you recall, in Java you can customize the exception. In Python you can do it too. This is just customize the warning, not customize the exception. Actually put it in the very back. You can actually read on your own how to customize the Python exception, because it actually also need to use the object-oriented programming concept. So it's kind of getting ahead of us. But if you really want to read into it, there's you can just Google look for Python customer exception. But this is a bit useful, but not too complicated in a way. So this is just an indexing error. So there'll be a few more, like trying to use the defensive programming to do the exercise. The superhero grid again. So in this time is actually, see here, this is again, this is an example for handling the exception silently. So instead when we're calculating the average grid, if like the data pool is nothing there, so if we just divide it, it will be divided by 0. But in that case, we actually just put instead of dividing by 0, we actually put a 0 there. So that seems to make sense though. So and another way of Python for the defensive programming is using the assertion. So assert something is there. This is actually kind of straightforward. So in this case, if we actually put the testing grid at the 0 there, that's the 0 there, then it's actually going to just stop the whole thing. So this is kind of a no-brainer. So I yeah, assert something. So oops. Yeah. So and if you want to read more into about the Python exception, the Python document is really the best source. This is also because Python is basically what we call a live programming language. It actually changes almost every quarter. If I recall, like 3.92 now. My recollection is it is changing every quarter. There's a new release I call, I'm not sure yet. But anyhow, it's changed quite frequently. So even for the other exception we use here, there's no guarantee it will still be the same in the new release of Python. So the best way to see how the exceptions are defined is still look at the actual Python language document. This is, I'm looking at the 3.2. Oh wow, look at this. There's the developer version of 3.10 coming. I don't know when that will be released. But apparently there will be a developer version of 3.10 is coming. So even though hopefully it doesn't change too much. So yeah, so 2.7, 3.5, 3.6, 3.7. So 2.7 is actually not even supported anymore. So even though the document's still there, but if you are interested, you can actually, if you sometimes you found Google found some example, but if it's a posting from very old, I don't know, 2.7 is which year? If it's a few years old code you run, it doesn't run. It may because it's from Python 2.7, which is not supported anymore. So I think that's what I have for today. Exception, I put some interesting video there on the canvas. There are some, it's a bit entertaining exception. Basically, I guess the idea is if you want to be exceptional in Python programming, you need to learn to use exceptions. It's a good idea. So if you want to be exceptional in Python, you need to learn exceptions. So it's actually quite funny. So yeah, I think that's all I have. So that's what I prepared for today. So.